Welcome to the project demonstration of heart rate monitoring and temperature monitoring along with audible alerts by using PIC microcontroller. So in this project mainly we are using components, pulse sensor to measure the heart rate of the person, temperature sensor for measuring the temperature of the finger when we place the finger on the sensors module, and continuously the data will be monitoring and displaying on the 16:2 LCD screen, and will get the audible alert through the buzzer whenever the abnormality detected. Abnormal ratings we set is when the heart rate is less than 60 beats per minute, and if it is above 90 beats per minute, and temperature is whenever temperature is above 99 degree Fahrenheit, then the system will provide us the audible alert through this buzzer. So we have interfaced the heartbeat sensor and temperature sensor to the PIC 16F72 microcontroller, heart rate sensor at A0 pin, and temperature sensor at A1 pin, and C4 for the buzzer, B2 to B7 for the LCD screen. So these are the main component interfacing connections to the PIC microcontroller. So here the heartbeat sensor works in such a manner like transmission receiving the LED signal. So whenever the LED transmits, so it has mainly two components: LED indication along with photodiode and amplifier backside of this sensor. So when we place the finger, so system heart rate is pumping the blood to the finger and pull back the blood from the finger. And whenever pumping the blood to the finger, then the finger will filled with the red blood cells. Then the receiving signal which was emitted by the LEDs, by the receiving signal to this photodiode is more, as the blood cells will reflect the more light. And whenever pull back the blood, then the low intensity will be received by the sensor. So based on this low and high, our system will estimate the time to get 1 beats. So for example, we will get the T in T time, the beats are going to be the 1, then the system will estimate the in 60 seconds a number of beats, and that will be displayed on the LCD screen in terms of BPM. Same for the temperature sensor also we are using to get the temperature of this surface of the finger. And coming to the motherboard, so on this motherboard we are providing power supply to the system through this adapter, which will take 230 volts AC and provide us the 5 volts of DC output. When we provide that, it start reading input from the input sensors and controlling the output modules. So on this motherboard we can see this is the reset switch. It will just do only resetting the microcontroller, and the steel plated one is the crystal oscillator which will provide us 20 megahertz of clock frequency to the controller. So the main purpose of this oscillation frequency is our controller need pulses to execute the steps, and one pulse, one instruction, like that the system will execute 20 mega instructions per second. And these two are the LED indications. One is the program LED indication, and there is a power LED indication which will show the power availability on the motherboard. So let us see the demonstration. So when you are on the power supply, your welcome message will be displayed on the LCD screen, and thereafter so the BPM will be displayed as a 0. So when we place a finger on this one, then we can observe the BPM will be calculated. Okay, so to make the high heart rate or low heart rate, just we need to tap very fastly over there to get the alerts, right? So high heart rate will be displayed on the LCD screen. In the same manner, just keep on tapping over there to get the alerts from the heartbeat sensor, right? And coming to the temperature, just we're increasing the temperature. So when it crosses the 100 degree Fahrenheit, then the system will provide us the audible alerts through the buzzer directly. Okay, so in this manner we are providing monitoring and alerting for the patients based on heart rate and temperature monitoring continuously. Thank you.